Here is an example. So in this example, he's asking about find the force between two conductors basically. So a rectangular loop of wire is placed next to a straight wire. There is a current flow of 3.5 amperes in each wire. So here is a straight wire. In physics, some of the examples, statement is not clear, so sometimes we need to assume some things. So um, he didn't say the current direction, so I'm assuming this is 3.5 ampere. Okay, and I'm assuming this current is also 3.5 ampere. Okay, I think I'm looking at my notes. When I look at my notes, he also give you this. So I'm assuming this direction is already given, and we need this distance. This distance is given as 3 centimeters. So this is given. I didn't mention this in the question, but this is already given. Okay, so take that as given information. So that's a 3 centimeters there. This is 5 centimeter. It's a rectangle. So it's a rectangle, so I don't know this distance. That's okay. I'm just taking that as B. Now I'm assuming current I is flowing in towards right. Here also current is flowing in towards right. So let me take this as conductor 1. This is conductor 2. So force F1, force on conductor 1 because of conductor, let me take this as A. Force on conductor 1 because of A equal to, or per unit length, force per unit length equal to mu naught I1 I2 over 2 pi r. This is the formula I just derived in the previous video. Okay, and that force, since since both currents are flowing in the same direction, that force must be attractive force. So this conductor is going to move towards up. Okay, so force on conductor 1 because of A is towards up. Mu naught is a constant. It's 4 pi times 10 to the power of minus 7. I1 is 3.5. I2 is also 3.5 divided by 2 pi times 3 centimeters, which is 3 times 10 to the power of minus 2. Okay, I think after calculating this, I have this value as 81.66 times 10 to the power of minus 6 Newton per meter. That's force per unit length on conductor 1 because of A. Now this conductor and this conductor, there won't be, there is a force, but that force is going to be, this one is pulling this side, this one is pulling this side, so it's going to stay together. It's not going to move in any direction. Okay, so now force on conductor 2 because of conductor A. Let me write it down here. Force on conductor 2 because of conductor A, which is also mu naught I1 I2 over 2 pi r. Here r is 8 centimeters. Okay, so 4 pi times 10 to the power of minus 7 times 3.5 times 3.5 divided by 2 pi times 8 times 10 to the power of minus 2. I have this number as 330 times 30.62 times 10 to the power of minus 6 Newton per meter. Okay, this force, since if you look at here, this current I is flowing in the opposite direction. Okay, so they repel each other, so this conductor is going to move away, so that force is going to be towards down. This is force per unit length. Okay, so the net force on the rectangle per unit length on the rectangle equal to, so one force is acting towards the long conductor, another force is acting away from the conductor. So force on rectangle per unit length equal to F1A per unit length minus F2A per unit length, and that's going to be 81.66 minus 30.62. It's going to be 51.1 times 10 to the power of minus 6 Newton per meter, and that's going to be towards up attractive force. Thank you.